With it finished. Yep. Yep. Yeah, if anybody has their math literacy completed and ready to resubmit, it'd be a good idea to get it done ASAP.
We want a high grade.
There's math literacy at the top. Well, I mean, if you were good with your score, you didn't have to, but I gave it back to be able to resubmit and earn more points. Told y'all that last Monday. All right, guys, you cannot take us 8.5 minutes to do this problem. If it's taking us 8.5 minutes, then we got something to learn. So let's talk about it. All right. Not, guys, remember, use your resources. So we got 2g plus 6 times g minus 9 is equal to 0. Pretty much 2 steps to solve this equation. For those who got 9 and negative 3, what did we do? 2g plus 6 is equal to 0.
Subtract the 6 on both sides.
Well, let's just pause there for a second. I appreciate that. We'll get there in a second. But 2g plus 6 is equal to 0. Is there anything else that we automatically know? G minus 9 is equal to... Can we just like magically do that? Or is there something that tells us this is true? I already gave y'all a huge hint. Come on, we gotta know what that ZPP stands for. Pause for a second, pay attention. You cannot just do that, guys. Zero product property. Guys, you have to set each factor equal to 0. And we gotta pay attention to this. Mathematically, I can't just magically put plus 9 and plus 9 here. That's not what's happening. Don't do that. Hayden, what does that zero product property tell us? You don't remember? You gotta know this. We gotta study this. Guys, I told y'all this once, told you this twice, maybe even 3 times at this point. The zero product property, it's gonna show up this unit, it's gonna show up next unit, and it's gonna show up the unit after that. Guys, we gotta study our vocab. We gotta know what these terms mean. Jalen, what you got? At least one of what has to equal 0? Like the name tells y'all everything. What are we doing here? What do we mean by a product?
A or B.
Huh?
A or B.
A or B, yes, but focus on that language. Product, what does that mean? Multiply, right? What are we doing with A and B, Jamarcus? We are multiplying it. The product is equal to what? 0. I'll point this out. Could 2 times 3 equal 0? No. The only way to get 0 at the end is if I'm multiplying by what? 0. So 2 times 0 would work. Or 0 times 3 would work. Or even 0 times 0 would work. Guys, the zero product property says if the product is 0, then at least one of those factors has to equal what? 0. You have to set those factors equal to 0. You have to do that. Now from here, it's solving it like normal. Preston, what would I do to solve from here?
Subtract 6.
Subtract 6. So 2g is equal to 0. Is that right? No.
Wait, no. Subtract 3 or 6 on both sides, right?
Do I need it subtracted from both sides?
Yes.
Why is that?
Why is this loading? What do you call it? I don't know.
Hello?
What do you call it?
Yes, ma'am. She has not. Oh. Sounds good. Yes, ma'am. Okay. So, we have to subtract 6 from both sides. Why? What were you saying?
I don't know. I got you.
Guys, we gotta know why. We gotta know the terminology. Somebody, terminology. Properties of Equality. What does that property of equality do? Like, what's the point behind it? That's what we're doing. It makes it equal. There's just a slight twist on that language. Makes the equations, say again, equivalent. What? So pause, guys. We gotta know our language well so we can talk about these things. What makes an equation true, Cam? What makes an equation true? Guys, if you're not involved in the conversation, you're going to be lost. Come on, Cam. What makes an equation true? It's the thing we're trying to find right now.
Solution.
Is that true? Yeah. Guys, solutions are what make the equation true. You right, Jose? You with that? Solutions make the equation true? The properties of equality make our equations equivalent. If I don't do it to both sides of the equation, I'm changing the equation entirely. And I do want a different equation, but I want them to stay the same even though they look different. Jayla, what am I going to do next? Divide by -6? I can do that. Notice that would give me a 1 here. So that would give me a -1/3 g equals 1. Did that help me solve for g? So what would I divide by instead? 2, you guess? Why are you all upsetty about it? You're not upsetty spaghetti today? Okay. How about, so tell me why we're going to divide by 2 then. So I'm multiplying 2 by g. I want to undo that multiplication with the inverse, so I would, you said it, divide by 2. Right? I want to undo the multiplication of between 2 and g, so I'm going to divide by 2. Now, what is the thing that I do recommend instead of just doing pure division by 2? I recommend the 1/2, because that's the same thing as 1 divided by 2. Remember, a number is always understood to be divided by 1. What is the name for that 1/2 and that 2 divided by 1? They are reciprocals. That language needs to start to become a part of our vocabulary. So I use my reciprocal there. And what is half of -6? -3. Guys, we gotta get comfy with that language. We gotta understand not just what we're doing, but why we're doing it. Yes,
Are we
ma'am.
gonna make a study guide?
For what?
Our exam.
Yes, your Venn diagram.
What?
What? That's a real study guide.
Okay,
No, you want me to give you a bunch of practice problems that are just like the test? Yeah, it's called your test. Guys,
Why you don't give us practice sheets?
I do.
I got 7
Do you want me to show you all the practice sheets I've given you throughout the semester? Because I've given you lots of them. Lots and lots and lots of them.
Need a new one with new problems.
Why? Have you mastered the old problems? Do you remember exactly what the equations are for the old ones?
That's why we get new ones so we can see like how to do it, like how.
Why don't
So it
you
can help us a little bit more.
Why don't you redo the ones you already did so that you have
We already know
answers? No, you don't. Like, here's the thing, guys. This is a graph that I've already given you in the past. Can you redo that and figure out if you truly do understand how to write the equation of that function? Yeah. And then you already have a check. The practice problems are on Schoology along with solutions. It doesn't help you to just do new problems that you don't know how to check to see if you get the right answers. You have the practice problems already. You have everything you need to be successful. We need to practice them. As soon as I see this equation, or this graph, I'm still thinking, that's a line, I'm looking at y equals mx plus b. I'm thinking through the fact that m, my slope, is rise divided by run. Okay, that's going up 3, it's going to the right 4. And then the y-intercept b is 1, 2, 3, 4, 5 down. So 0, negative 5. So y equals 3/4 x minus 5. That is literally a practice problem. That was on a practice sheet we did in class. It was also on your test. And we still missed it. We need to know these things. So you have the study guide. The vast majority of your midterm are the exact concepts that were on your test. There are 4 pages to your study guide. 3 of those 4 pages are based exactly on what we had on our test. The last page is what we've been doing recently, writing the equation of a quadratic function when given a graph or given a couple of points, and then solving equations. So what we are doing today is going to help you prepare for that midterm as well. But you have everything you need. And that Venn diagram, you should study that heavily for your midterm. For your midterm. I told y'all that before the last test. Literally, I said, hey, you need to study this study guide, or this Venn diagram. And what was on your test? That Venn diagram. And if you had taken the time to write out your equations for a quadratic function, could that have significantly helped you on the test? If you had written out a table and a rate of change, that would have significantly helped you on the test. If you had written out the equation of a line and said m is rise divided by run, or the change in y divided by the change in x, that's my constant additive rate of change. And that this is my y-intercept when x is 0. On that Venn diagram. That would have been more evidence that you understand what a linear function is, but would that have also helped you on the test when you had to write an equation for a linear function? So you have everything. It's not doing new things. It's going back to the foundations that we have been doing over and over and over again. Now, I was planning on doing factoring today and tomorrow, and then reviewing Wednesday, Thursday, especially because y'all's exam's not till Friday. But what we're doing today is going to help you prepare for the test as well. The pre-assessment will also help you study for your midterm. So we don't need new practice problems. It's more beneficial to have the solutions and check to see if we can do it. Write the problem on a separate sheet of paper and work it out. Or go to the Schoology, or even ask me, and I'll be more than happy to print out an extra sheet for you. But understanding why here, not just copying down the answers, is going to help you. Does that give you some insight? Miracle, were you the one asking for the practice, or was it Treyana?
Me.
Is you? That's exactly what I would do. And I need y'all to understand, like, that's not just me trying to be lazy. That's what I did. That's what I do to study. Is I do practice problems that I already have solutions for. That way I can check myself after I get done. It doesn't help you just have brand new ones. Yes, ma'am.
So basically what we gotta do to look at test is like looking at like our worksheets that we already did.
Yeah. There's nothing new on there. Look that up. Yeah, I will. Yeah, guys, you have, there's nothing new except for the stuff that we have already been over time and time again. What's up? Ask your question, go for it.
I'm just a little bit confused.
What are you confused on?
probably not doing a study guide.
What do you want in a study guide?
Basically, like, practice problems, from what we already do. And like, basically, we just go over, like, some definitions of the words that we've been talking about. And all that, like, all that we already did, so we
We need
can
all
at
the
least
homework.
be prepared for the midterm.
That's what your notes are for. That's what I mean, I can tell you the topics and go back over it, but here's what you gotta know. Yes, finally to end it, plus 9, g equals 9. You gotta know linear, you gotta know exponential, and you gotta know quadratic functions. You gotta know their rates of change, how they appear in tables, which would be based on their rates of change. You gotta know the equations, and you gotta know their graphs. You have to know how to write the equations. You gotta know how to solve equations. Which would involve your inverses, properties of equality, and what's the other thing? Oh, equivalence. All of this is on your test. It's on your pre-assessment. All of those things. You have your textbooks. You have your notes. Guys, we're juniors and seniors in high school. You are not going to get that in college. You've got to go through your notes. Okay, we got a sophomore in this. Same thing still holds true. Like, none of this is brand new information. You gotta know the rate of change, you gotta know how they appear in tables, you gotta know their equations, their graphs. Like, straight up, if you study your test, you study your midterm, or study your pre-assessment, you will have all the information you need. Now, you will get extra details from your notes, extra details from the textbook, but that's what's gonna be on your test, on your midterm. Yes, Rakai,
When do I get my test back?
today. Okay. But I gotta tell you, the biggest problem that a lot of us have, and I know you're gonna be like, but Mr. Kinney, we don't understand. Yeah, if you don't know your equations, it's really hard to understand. If you have not taken the time to learn your equations, it's going to be impossible to identify, oh, that's the last thing. Identify features of quadratics from the equation. Identifying features of quadratics from your equation. So if you don't know your equations, it's going to be next to impossible to be successful on the test. You got to know those things. And we will get review for 2 days in this class, Wednesday and Thursday, where we do practice problems. But also I need to emphasize and remind you, it's not just knowing what to do. If you don't understand how and why, then you're going to get lost on a test that expects you to understand. You've got to understand. Is there anything that I need to clarify language-wise that's up there? Or questions, burning questions you have about being successful? will point out, if you try to do your best to make sure to understand, you will be successful. Y'all just want to do practice problem after practice problem until you've mastered what to do. Understand the how and the why first, and then do a few practice problems. Because if you just do 1,000 practice problems and figure out what to do, you will forget it within a couple weeks. That's not helpful. Understanding how and why will help you long term. And also, some of us just got to study. Got to take the time to read through our notes to understand how and why. We're still ahead of the other classes. Let's do another practice problem. The practice that you so desperately want. So, solve this equation. If you want to get up to the whiteboards or any of the vertical surfaces, be my guest. I highly recommend it.
No, because I'm actually really good at math. I'm telling you, it's just the way you.
The 5 is the square root of
Right.
5. So I'm going x minus 3 equals 5.
Like, I know, I mean, you have business people.
And where'd you get your book from?
Yeah.
The x minus 3.
Huh?
I can see her on his home. I know what I got.
Oh, wait.
You put 28.
You could, gauge.
I'm gonna put you're right.
It's okay, because I'm watching in next month, if not next month, in early.
Dude, I want to do something like that on this test.
Can I do it?
But I think that actually. Oh, I got it.
I've been having.
You can talk me through it, but I want to talk about these things. So first things first. Right here, we got an 8 for a whole lot of us. How can I check to see if 8 is a solution?
Plug it in.
Plug it in.
What's that more mathematical term? Substitute it in? So let's check. We got calculators, it makes it nice and easy. 8 minus 3 squared plus 8, does that equal 58?
Yeah. Type that in real quick. Yep.
You didn't type that in.
So I did.
No, you didn't.
Oh, my calculator just like backed me out.
So let's substitute that in. Let's check to see if it makes the equation true. Yes?
Yeah.
Okay. So, true? Yes? But I see some people up here got a -2 as well. Before you type it in, eyes up here. I want you to pay attention to this. What is 8 minus 3? 5. And when I square 5, I get 25. What's -2 minus 3? -5. And what's -5 squared?
25.
That's also 25. So I get 25, whether it's a positive here or a negative, because when I take a square root, when I take a square root, how many values should I get? 2. When it's quadratic, how many solutions should I have? 2. And guys, here's what I need y'all to understand, because this is going to be a game changer if we learn this detail. You don't need to do 1,000 practice problems. You need to understand how and why. You need to understand why you're doing what you're doing, and then do a few practice problems applying those ideas. Like the first thing I want to point out here is, why am I not using the zero product property for this equation? Last time we had 2g plus 6 times g minus 9 was equal to 0. We used to use the zero product property there, huh?
Nothing equals 0.
It's not equal to 0. There's another reason, right? So first off, it's not equal to 0. What else? Listen to that wording.
There's not two terms. or
Two
equations. Two sets of parentheses.
sets of parentheses. Hey, what's between these two sets of parentheses? Multiplication. It's not two factors. Doesn't that look like the factored form of a quadratic equation? As soon as I see factored form equal to 0, I'm thinking zero product property. Do I have factored form in that blue equation that I sent out to the calculators?
No.
No? Tyson, what form do I have in blue right there? Do you remember? Tyson, I need your headphones out. I need your headphones out. Say again?
Vertex.
Oh, that's the vertex form. Right? A times x minus h squared plus k. As soon as I see vertex form, notice there's only one value or one place where I have an x. As soon as I see vertex form, what am I using? Shania? As soon as I see vertex form, I'm not using a zero product property. What am I using to solve this equation? Would you use all the way through? It starts with an I. Ends with inverses. Guys, if we understand that language of zero product property, oh, I have factored form equal to 0, so I set my factors equal to 0. If I understand that I have a vertex form equation, I'm using my inverses. And then I use them by using PEMDAS backwards. You can think of it that way, or whatever the last operation is, that's what I'm undoing, right? Jayla, what is the first thing happening to this x right here? Being subtracted by 3, I got to take care of parentheses first. But I don't know what x minus 3 is. Jamarcus, what's happening to that x minus 3? What's the very next operation?
Squared.
It's being squared, right? Exponents before anything else. All right, Desiree, what's happening to x minus 3 squared? Being multiplied by 2. Multiplication happens before addition, right? Treyana, what's happening after we multiply by 2? What's happening after that multiplication by 2? What's the only other thing on adding by? 8. Tevin, is there anything else on that left-hand side of the equation? After we add by 8? Remember, we already took care of the 2. Remember, we said x minus 3 is squared, then times 2, then plus 8. Is there anything else? No. So, Rakai, what's the last thing we just said there? What's the last thing we just said? Well, yes, but what was the last operation we identified? Adding by 8. So, Hayden, what do I do? Well, it's already being added by 8. Subtract by 8. Guys, understand what you're doing, not just randomly doing stuff. The last operation being applied, that's the first one I want to undo. So 8 minus 8. 0. Marshall, what's the next, or now what is the last operation being done? Multiplication by 2. Does anybody want to add on to or push back on that multiplication by 2 is the last operation?
Division.
So, are you saying that right now there's division, or that we need to divide?
Right now. Oh, we need to.
We need to divide. So, here's the thing to remember. I will point this out. Don't forget. Can you divide by 2? Yes. But I recommend that times 1/2 to help you with writing exponential equations. As soon as you see division by 2, multiply by 1/2, right? Because that is 1 divided by 2. Here's why, as a quick refresher, because this is going to be on your test, here's why I recommend that. Okay. Naturally, I want to point this out. When I look at 27 to 9 to 3 to 1, I see that as division by 3. But it's going to be hard to write that equation. So instead of division by 3, I'm going to write that how? Times 1 divided by 3, or times 1/3. As soon as I see division, I rewrite it as that multiplication by a fraction, because that makes writing the equation easier. That's it. That's the whole purpose behind it. Well, and also it's beneficial to understand the reciprocal, but that's the main reason. So times 1/2 times 1/2. Now don't forget, Eliza, why do I have to multiply by 1/2 on both sides of that equation? Like, we know we're creating a 1 here, but why both sides?
I don't remember which time, y'all know which one.
Okay? So, even if you don't remember what it's called a property of equality. Why do we have to do it? Why is it that whatever I do to one side of the equation, I do to the other? So you know the procedure, but what's the why? Why do we do these things? Okay, we gotta know
Keep
this.
both sides equal.
Keep,
Equivalent.
say it again.
Equivalent.
Equivalence. Is this equation different than what we started with? Does it look different? Yes? But Jacoby, do I want it to have different solutions? No. So I need equivalent equations. It's not random. I have to do whatever I do to one side of the equation, I have to do to the other to create equivalent equations. Shania, what am I doing now? What are you doing?
Oh, I fill out job application.
This is a math class, not job application. I do want you to get a job, but we gotta do math.
I gotta put-
What are we doing now?
But it ain't no funny. Oh, you got, square root both.
Okay.
Can you use a different color? It's gonna cancel out the exponent.
Okay, that square root undoes the square.
And it undoes the parentheses.
Okay. Okay, so let's talk about that just conceptually. It's not that it undoes the
It
parentheses.
just takes out parentheses.
Right. Parentheses group things, right?
Yes.
And that's to tell me that I need to subtract before I square. Well, now that I've taken care of that exponent, I don't need the parentheses anymore. But Preston, here's one of the things that we've got to be careful about. What do I need to write on the right-hand side of this equation? X minus 3 equals what?
5.
Is that it?
Plus and minus.
Yeah, we have plus or minus.
That's a great question. Anybody want to help us out? Why do we need to put plus or minus?
Because
it
they're
can be
both
either or.
equal 25.
Well, both of them.
They're
They're
both
both
equal the same thing. Either. Oh, I'm stuck.
You're good. Look, guys, remember, right here, with solving this equation, when I take a square root, what I'm asking is, what was squared to get 25? Well, 5 squared is 25, right? Is there anything else squared that gives me 25?
Negative 5.
So I need both a positive and a
Negative.
negative. Last step now, and I do want to point this out. We have to be careful with this, right? David, this is what you originally wrote, if I remember correctly. Right? You were like, Mr. Kinney, is that right? What's the issue here, though? Yeah, where's that plus and minus? It's on the 5. So can it go on the 3?
Nope.
Nope. Positive negative 5 plus 3. Notice, what is 5 plus 3?
8.
8. What is negative 5 plus 3?
Negative 2.
Remember how those were the solutions we checked at the very beginning of all this, and they both make the equation what?
True.
True. Okay.
I need to write it down.
Okay. So Grace, big picture time. If you have the standard form, or not standard form, if you have the vertex form of a quadratic equation, what do we use to solve that equation? If I see this vertex form and I want to solve that equation, what am I going to do? No, you're not going to ask Mr. Kinney because you got to do this on your own.
What do you mean by it?
We're going to use what? Miracle's telling you. I'm going to use inverses with properties of equality. That's it. As soon as I see vertex form and I'm trying to solve the equation, notice I'm not asking for features and we need to be careful about this. Is this a vertex, is this a function in vertex form? To have a function, we need inputs mapping to
Output.
outputs. So does this have both an x and an f of x? Do you see a y up here or an f of x up here?
No.
No. So I'm not going to ask you about the features of this function because it's not a function. I'm going to ask you to solve it. You've got to pay attention to that big picture part of it because I'm asking you to integrate multiple skills. Unfortunately, we're very used to tests that have small sets of skills where they only ask us to solve equations, where they only ask us to identify features. But that's not gonna help you long term. If you are a junior and you're taking the ACT, they're not gonna say, hey, do this one thing. They're gonna throw lots of problems at you and you have to identify what's happening so that you can solve the equation, so that you can identify the features, so that you can do blank. The ACT, you will have to know how to make a table off a word problem, make a graph off a word problem. You've got to think through these things, and if you're going to college next year, you've got to identify big picture what's happening. So, what are your questions about why we did what we did at certain points? The square, so the inverse of a square is a square root. Because they are inverses, they cancel each other out. Technically, they make an exponent of 1, because we're always trying to create zeros and ones. Okay? I will point out the easiest way to figure out the order is whatever the last operation is, that's the one you want to undo. I was not planning on getting to this point over halfway through class, but the rest of our agenda, first off, what did we learn last Friday? If you missed last Friday, it's not something you have to make up, but hopefully it was fun and engaging for the majority of us. What did we learn about? We did those tracks, right? But what was that to help us talk about, like in the physical world? We talked about gravity, and we found out that gravity follows what type of function? A quadratic function. Like make it warmer?
Is that true, or was it?
I mean, we saw it. Like that's not him bullcrapping. Like when we graphed those data points, that was using gravity. What shape did that graph have? It had a quadratic curve, right? A parabola. Like you collected the data, and I want y'all to think about it. If I were to throw shoot a basketball, right? What shape would that follow? Doesn't that follow quadratic curve? Actually, technically, it ends up higher. But it's going to hit its vertex, its maximum, and then hopefully it goes into the basket. If someone throws a football, unless it's just a beeline, what shape does that football follow for its path? Follows a parabola, right, to get to the receiver. If someone hits a baseball, which we see it more there than when we throw it, although we do see it when you throw long distances. If someone hits a baseball, what shape, or a softball or whatever, what shape is it going to follow? Parabola, quadratic, where it goes up and comes back down. Everything that involves gravity follows a quadratic curve. Every single time. You talk about cars. When we talk about cars stopping speed, their stopping distance follows a quadratic curve based on how fast they're going. Every time. Quadratic functions are not things that are random. They appear in the natural world. Higher order, a little bit more random, but because we've established a pattern, we continue that pattern. Okay? So yeah, he was not bullcrapping me.
I thought it was.
No, like you collected the data, you saw it. You saw the shape of those points, didn't you?
Yeah, but I mean,
Did he make up that data, or did you collect it as that car went down?
I don't know, he could have been controlling them.
You all got different values. No, he can't control all that. All right, so please remember, guys, you are super capable. That's why I ask you to say that every day you walk in. But we've got to get out of our own ways. And what I mean by that is this. If you don't know the zero product property yet, and you don't know what it means, you got to take the time to study it. You got to know that language. If you don't know that it's the properties of equality that tell you whatever you do to one side of the equation, you do to the other, because that creates equivalent equations, you got to know that. All of these things are things that we should have taken notes on. The pre-assessment has every note that you should have for the unit that we're studying right now. Every single thing. The zero product property showed up there. The idea of using inverses to solve equations, it shows up there with those properties of equality. You gotta take the time to study your notes. If you don't, you're gonna come in confused. Even if you just took 5 to 10 minutes a day to look back over your notes, it would pay off huge dividends. You could do that during enrichment. You could do that when you get home. But if you don't know the mathematical language to be able to talk about these things, if you don't understand the how and the why, the actual doing is going to be very difficult. Y'all are used to just learning a procedure that you do over and over again without understanding how and why, so that when you have multiple things to do, you get lost. You have to understand the how and the why. Yes, Eliza?
Why you divide two on both sides?
Great question. So like, why did I do it there, or why did we divide by 2 in general?
Both.
Okay, so when I look at this equation right here, first thing happening to x is we're subtracting by 3, right? X minus 3 is then being squared, then x minus 3 squared is being multiplied by 2. And we do need to recognize, because I did see someone who subtracted 2 here, but I'm not adding 2, I'm multiplying by 2, right? Multiplication by 2 is the last operation being done, it's the last thing I read off, and what's the inverse of multiplication? Division. So I'm multiplied by 1/2. Notice, half of 2 is 1, right? And also that is 1 divided by 2. It's telling the same story from different perspectives. Does that answer your question? You get there? Okay.
Can you try
Forehead? Doesn't rub it.
to make you go crazy on camera?
I mean, you know. I am crazy, so it's okay. Alright, so this week, this week, we're finishing up, not finishing up, but we're going to work on learning how to factor quadratic equations and solve quadratic equations. There's 2 things out of that, and I know it's going to sound like it's a brand new skill. There's only 1 question, 2 or 3 questions where you have to factor on the midterm. But it's going to help us talk about the factored form of quadratic equations as well. And so be aware of that. And then Wednesday and Thursday, we'll be taking time to review for your exam. So here we are in the textbook, Module 1, Topic 1, Lesson 5. The root of the problem, this is all about what? Solving quadratic equations. We've already established it. If I have the vertex form of a quadratic equation, what am I using? I'm using inverses with my properties of equality. Thank you. So we're going to use those inverses with properties of equality. If I have factored form, what can I use? Guys, if I have factored form, what can I use? Right here. Zero product property. That's exactly what we're going to do. Okay, so that takes us through all this. Notice, here's your practice problems with vertex form and using inverses. This is 4 different levels of difficulty with solving those equations. We'll get more practice soon, but you can very easily write those equations down on a separate sheet of paper, work them back out, and then you have practice problems to check against where we have solutions. You also can go on, I need to update the timestamps, but you can go on YouTube and find where we talk through the solving of these problems if you get confused or lost. So it's more beneficial to work out these problems that we've already done and make sure you can understand and explain it, and go watch those YouTube videos to help with that. Alright, so here's one thing I will point out. I think we've already talked about this. With Oscar here, this is the same as A, right? We saw it as vertex form. We used our inverses, but Oscar did not. He got his equation equal to what? What was the first step he did? Get his equation equal to? And then he what? He got factored form. He factored it out so that he could use the zero product property. And it gave him the exact same answers. And so what we are learning here is how to factor. You should have notes on this page. I'm going to quickly go back through these ideas, and we're going to do one, I guess we're going to do one together to make sure everyone has these notes. But first things first, we see in the worked example, they get their equation equal to what? 0. Why? Because they want to use what property? The zero product property. I need y'all to hear me very clearly on this one detail. If you have x squared minus 4x plus 3, what form of a quadratic equation is that? That's standard form. You cannot solve a quadratic equation in standard form. So you have to get it into which form? What said? I've barely gotten anybody. Chill.